In this tutorial, we will create a model of simple assembly using glued contact conditions automatically generated by Femap and then solve the model using an XNAS-TRAN. We will work through the entire Femap analysis process, which includes importing the geometry of the assembly, creating connections between different parts of the assembly, meshing the model, applying loads and constraints, analyzing the model using NX NAS-TRAN solver, post-processing the results. To import geometry, we go to File, Import, Geometry. We import the parasolid file. In Solid Model Read Options dialog box, click OK. Now, we will be creating connections between the different parts of the assembly. To create connections automatically between the parts of the assembly, click Connect Automatic. In Select Solids to Detect Connections dialog box, click Select All and then click OK. In Auto Detections options for Connections dialog box, under the connection type, select Face to Face. Under Connection Property, select Glued, leave the rest as default and then click OK. We will now notice that there are new connection regions which are visible where the parts come together. Let's take a closer look at each connection property, connection region and connector created using the connections branch of the model info tree. Let's expand the connections branch. Click on the plus sign to the right of the title to see the different connection entities. We will notice that 2 connectors, 3 connection regions and 1 property was created in the model by automatic contact detection. Let's create loads and constraints. To create load, click Model, Load, on Surface. In the new Load dialog box, type Load and click OK. In the Entity selection, enter Surfaces to select dialog box, pick the front round surface of the plunger and then click OK. In Create Loads on Surface dialog box, highlight Force from the selection list. In Direction selection, select Normal to Surface. Enter 100 in the magnitude field of the load selection and click OK. To create constraints, click Model, Constraints, on Surface. In the new Constraint dialog box, type Pinned, click OK. In the Entity selection, enter Surfaces to Select dialog box, pick the 4 surfaces of the rear holes of the base link, and click OK. This will bring up the Create Constraints on Surface dialog box. Create Constraints on Geometry dialog box, click Pinned No Translation and click OK. Let's mesh the solids using Model Info Tree. In the Model Info Tree, expand the Geometry branch, click on the plus sign to the right of the title to see the different geometry entities. Highlight all of the solids by selecting the first solid in the list, then holding the Shift key down and selecting the last solid in the list. Click on the right mouse button on the highlighted solids. When the context sensitive menu appears, choose Text Mesh command. Femap will prompt you to make a material to be used for all the selected solids. In the Define Material Isotropic dialog box, click on Load. Select from Library dialog box 4340 Steel and click OK. In the Define Material Isotropic dialog box, click OK. In the Auto Mesh Solid dialog box, click OK. The model is now ready to be analyzed. Let's create the analysis set and solve the model. Click on Model, Analysis. In the Analysis Set Manager dialog box, New. In the Analysis Set dialog box, keep the title as Glued Contact. Select NX Nastran from the Analysis Program drop-down list. Then select Static from the Analysis Type drop-down list. And then click OK. Click on Analyze. The Analysis Monitor window will display the status of the solve. We will know that the solve is done when the Messages document pane tells you that the cleanup of the output set is complete. To display the deform model and the solid one mice stress, click on View. Select, choose Deform Radio button in the Deform Style section. Choose Contour Radio button in the Contour Style section. Click Deform and Contour Data button. In the Select Post Processing Data dialog box, select Output Sets as Nastran Case 1 in Output Vector section. In Deform, select Total Translation. In Contour, select Solid 1 mice stress and then click OK and then click OK again. We can see in front of our screens the result for 1 mice stress. Thank you for watching our tutorial.